This is going to be our video for Unit 6, Day 3. So far in this unit we've covered some of the basic ideas of geometry, we covered some basic vocabulary, and yesterday we got into parallel lines, angles, different sort of geometry problems where we see where it's not just so much the numbers and the vocabulary, but it's also kind of the reasoning behind all this stuff that really getting to in these geometry problems. So we're moving now from where we just have vocabulary, we started working with lines and angles yesterday. Now we're going to actually move into shapes today and for the next video. So there we're going to look at perimeter and area of different polygons. So polygon is a two-dimensional figure. Two-dimensional figure that has angles and straight sides. So basically any shape that has sides and corners. Or really any shape that's not a circle or a piece of a circle. Is what we call a polygon. So with polygons, there's two things you're interested in. The distance around the outside of a polygon. That's called the perimeter. And then the second thing is the area, which is the space inside the polygon. So different polygons have different formulas for finding the area. So we're going to go through different types of polygons as well as their area formulas. But for any polygon, to find the perimeter, you're just going to add up all the sides. So all these polygons you've seen before, you've seen the shapes. We're just going to make sure we're very comfortable with the definitions for these shapes. So first one is a square. There's a definition for a square. Square is a polygon that has 4 congruent sides and 4 right angles. Square is a type of quadrilateral, which means a polygon with 4 sides. So a bunch of these different ones are going to be quadrilaterals. All that means is it has 4 sides. So if this shape on the left here is a square, what we'd look for in a diagram is it has to be marked with all 4 sides equal and all 4 angles right angles. Find the formula for a square, we take the side length and we square it. That's where we get that term from, squaring it. So here's an example over here. It tells us that this is a square, which means we know right away that these are all right angles and that all the sides have to be equal. In this case, their length is 3. So to find the area, I'm going to square 3, which is 9. Find the perimeter, I'm going to add up all the sides. So there's 4 sides of length 3, so perimeter is 12. Next polygon we're going to talk about is a rectangle. So square, rectangle sometimes gets used interchangeably, but there is a difference between them. A rectangle is a quadrilateral, means 4 sides. That has 4 right angles. So square is actually a special type of rectangle. So this is where you hear people say all squares are rectangles, but not all rectangles are squares. So square is a special type of rectangle. And one special property about a rectangle, even if it's not a square, you'll always have the opposite sides, so the sides across from each other. Opposite sides of a rectangle will be congruent. Again, congruent means equal in measure. So if we look at this picture here, to know for sure this is a rectangle, what we need is 4 right angles. But what we get from that property is that we know that these two lengths will be the same opposite each other, and these two lengths will be the same opposite each other. The way we get the area for a rectangle is, you've probably seen this 100 times before, base times height. Or if you use length times width, that means the same thing. So again, now we're going to do an example of this. So find the perimeter and area of the rectangle. Again, if it's a rectangle, what we know is we know all of these are right angles, and we know the opposite sides are congruent. So this has to be a 5, this has to be an 8. Find the area, I'm just multiplying base times height. So that's 8 times 5, so our area is 40. Find the perimeter, just adding up all the sides. So 8 and 5, and 8 and 5. All together makes 26. Alright, third polygon is a triangle. Again, you guys know what a triangle is, pretty easy one. Triangle is a polygon with 3 sides. Alright, so quadrilateral has 4 sides, triangle has 3 sides. When you find the area of a triangle, this part's a little bit different. The height won't always be one of the sides. You have to use the perpendicular height. We talked about what that meant the other day in our vocabulary video. The perpendicular height means coming down at a 90-degree angle from the top of the triangle to the base. So to show you what this idea means here, perpendicular height. So if I go from the very top of the triangle straight down to the bottom at a 90-degree angle, that would be the height. Find the area for a triangle, it's half of base times height. So it's like half of the rectangle formula. So it's a little bit tricky since the height won't always be a side of the triangle like it is when we do the area for the rectangle or the square. So for our example here, we see our triangle. This 4 is the height. So it's not actually side length, so we use it for the area. 1/2 the base is 6, and the height is 4. So 6 times 4 is 24, and half of that would be 12. For our perimeter, we're just going to add up the 3 of these that are actually sides of the triangle. So we'd add up 5, 5, and 6, which is 16. We don't add the 4 because the 4 is not a side of the triangle, it's a height. We just have to calculate the area, but we don't include that in the perimeter. Alright, so just got 3 more for you here. Number 4 is a parallelogram. So a parallelogram is another quadrilateral, like the rectangle and the square. Has 4 sides. What makes it a parallelogram is that it has 2 pairs of parallel sides. That's why it's called a parallelogram. So just like with the rectangle, opposite sides of a parallelogram are congruent, and opposite angles in a parallelogram are congruent. So this actually means that a rectangle is the type of parallelogram as well. It fits all those descriptions. And again, this is similar to in the triangle, what we did with the triangle. We find the area of a parallelogram. We're not going to be using, unless it's a rectangle, we're not going to be using one of the sides as our height. We're going to have to use the perpendicular height from the top to the base. And so again, you see what this looks like over here on the example. Since it's a 90-degree angle, that's why it's perpendicular height. So again, you see the note there is the same as the area formula for a rectangle. Since a rectangle is a parallelogram, it's a special type parallelogram. Area for a parallelogram is just base times height. So again, just like with the others, we're going to do an example. So we're going to find the area and the perimeter of this parallelogram. So here my base is 15, height is 4. So 15 times 4, or 60, is the area. Perimeter, right, we only have two sides here, but we know that properties in the description, opposite sides are congruent. So perimeter, I'd add up 15 plus 5 plus 15 plus 5, 40. Alright, next one has probably the hardest formula for area to remember. That's the trapezoid. So trapezoid is just like the parallelogram, and the rectangle and the square is a quadrilateral. It has 4 sides. And this one's a very similar definition, but it's different from the parallelogram. The parallelogram had 2 pairs of parallel sides. Trapezoid has exactly 1 pair of parallel sides. So just like with the parallelogram, if we find the area for a trapezoid, we need to use a perpendicular height and not one of the sides, unless one of the sides is already coming at a right angle from the top to the bottom. It always has to be the perpendicular height. So our 2 parallel sides is how we know we have a trapezoid. Right, when it's a parallelogram, we have 2 pairs of parallel sides. On a trapezoid, we only have 1 pair of parallel sides. So those parallel sides are what we call the bases. So that's what B1 and B2 are, is the 2 different bases, the parallel sides. So to actually find the area, it's 1/2, and then we actually add the 2 bases together. So base 1 plus base 2, and then multiply that by the height. So I'll show you how that formula works here with our example. So again, we can see from the picture, it tells us, that should say trapezoid. It tells us it's trapezoid. which means we have the one pair of parallel sides, those bases, and again we can see um, which those are by looking at the picture. The 6 and the 8 are the two bases. So to find the area, I'm using this perpendicular height 4, so it's going to be 1/2, add the two bases, that's 8 plus 6 times 4. So 1/2, 8 and 6 would be 14 times 4, and then multiply those out. Half of 14 is 7, 7 times 4 is 28. Perimeter, which can add up the sides, and again, like with the parallelogram and the triangle, let's be careful, do not include the height as one of the sides unless one of those sides is perpendicular, and it actually is the height. Don't include the height, so we're just going to be adding up 8 and 5 and 6 and another 5. So 8 and 5 would be 13, 6 more is 19, and 4 more would be 24. Alright, this is the last one, last piece for the notes. Last polygon we're going to cover, this one's called a rhombus. So rhombus is another quadrilateral. So all the ones we've done have been quadrilaterals except the triangle. What makes a rhombus that it has 4 congruent sides. And opposite angles are congruent. So what that looks like on a diagram, what we know it's a rhombus is all 4 sides are congruent, marked the same. The opposite angles are congruent. This is another tricky area formula like the trapezoid was, because what we're going to actually use to find the area is not any of the side lengths, it's actually going to be what are called the diagonals. So connecting opposite corners of the shape. Call one of them D1, call the other one D2. These are called the diagonals. To find the area, we actually use these two numbers. We take half of the product of the diagonals, so 1/2 times D1 times D2. So again, we're going to try the same thing with this shape. So here, we got to fill some things in. So we say that's a 5. This diagonal has a length of 6, and this diagonal has a length of 8. To find the area parameter of this rhombus. So since it's a rhombus, what we can fill in that we know is that all the sides have to be the same. So that will help us do the perimeter. And for the area, we're going to be multiplying the two diagonals. So we say that 8 is diagonal 1, 6 is diagonal 2. So area is going to be 1/2 times 8 times 6. So half of 8 is 4, and 4 times 6 is 24, would be the area. For the perimeter, again, just adding up all the sides. 5, 5, 5, and 5. So that would be 20. So that's all the different polygons we're going to cover in here. All the ones you'll need pretty much for Math 2. Only other thing we're going to point out, since we've done all these different definitions, so a lot of them are very similar, and that's that some of the definitions actually fit inside other definitions. A square is also a rectangle, since it's quadrilateral with 4 right angles. It's also a parallelogram, since it has 2 pairs of parallel sides. And it's also a rhombus, since it has 4 congruent sides, and opposite angles are congruent. So if you want to see any other explanations for this or any extra practice problems, you can search for polygon, area, and perimeter. Um, Otherwise, you can use, you're going to get a second sheet with some practice problems on it, so you're just going to have to look at those problems on the second sheet, figure out what type of shape it is, and then find the area, perimeter, and actually say what type of shape it is. So do the practice, and we will go over it on the practice. For this one assignment, you will be able to use a calculator because the worksheet has some tricky numbers in there. So for this one thing in class, you can use calculator on the practice worksheet.